Clair Patterson wanted to measure time, not hours, not centuries, geological time. He was a geochemist, working in the late 1940s, trying to determine the age of the Earth. This mattered because geology lacked a fixed timescale. Without it, Earth's history could not be measured precisely. Patterson used uranium-lead dating, a method based on radioactive decay. Uranium slowly turns into lead at a known rate. The ratio reveals age. The physics was solid. The math was clear. The samples were not. Every rock he tested contained too much lead. The numbers did not agree. Different samples, different locations, same problem. The lead did not belong there. Patterson assumed error. He cleaned equipment, replaced containers, filtered air, changed reagents. The lead stayed. He built one of the cleanest laboratories in the world. Sealed rooms, filtered airflow, strict procedures. Still, lead. That was the turning point. The contamination was not in the rocks. It was everywhere else. Lead was in the air, on surfaces, in water, in dust. At the time, this was not surprising to industry. Lead was widely used. Paint, pipes, solder, food cans, fuel. Gasoline contained tetraethyl lead, added to prevent engine knocking, burned in billions of engines, released into the atmosphere. It was assumed to be safe. That assumption had never been tested at scale. Patterson decided to measure it. He sampled rainwater, ocean water, air particles, soil, ice. He compared modern samples to ancient ones, ice cores, deep sediments, materials formed before industry. The difference was extreme. Ancient ice contained almost no lead. Modern ice contained hundreds of times more. The increase was sudden, recent, sharp. The timing matched exactly. Lead levels rose with leaded gasoline use. They spread with global traffic. They reached remote regions. Even the polar ice caps recorded it. This meant something important. The contamination was not natural. It was not geological background. It was human-made, and it was global. Patterson published his findings, quietly, carefully, with measurements, not language. The response was immediate. Industry objected. Oil companies, lead producers, chemical manufacturers. They challenged his methods. They questioned his controls. They claimed environmental lead was harmless. Some said the body could tolerate it. Others said the data was exaggerated. Patterson returned to the evidence. He measured lead in human bones, ancient skeletons, modern ones. The contrast was clear. People who lived before industrialization had almost no lead in their bodies. Modern humans carried it from birth. Lead accumulates. It does not degrade. It interferes with biology. This was already known in small settings, factories, paint exposure. What was new was scale. This was not local poisoning. This was planetary. Patterson showed that lead from car exhaust became fine particles, small enough to travel far. Inhaled, ingested, deposited into soil and water. Food absorbed it. People absorbed it. Children absorbed it most. He testified before government panels. He challenged regulatory thresholds. He criticized standards written with industry data. This had consequences. Funding became difficult. Research invitations stopped. Committees excluded him. At one point, he was removed from advisory roles, not for being wrong, for refusing to soften conclusions. He continued. Other scientists replicated his work. New instruments confirmed his measurements. The signal stayed consistent. As leaded gasoline use expanded, lead rose. Everywhere. When controls were introduced, it fell. Public health data followed. Children with higher lead exposure showed reduced cognitive performance. Urban areas with traffic had higher blood lead levels. The correlation was persistent. By the 1970s, the evidence converged. Leaded gasoline was not safe. It never had been. Regulators acted slowly. First limits, then reductions, then phase-outs. Unleaded gasoline became standard. Not overnight, over decades. The results were measurable. Blood lead levels dropped. Environmental lead declined. Ice cores recorded the change. This was not symbolic. It was physical, recorded in chemistry. Patterson lived to see the shift, but that was not his original goal. Along the way, he solved his first problem. In 1956, using ultra-clean techniques, he measured the age of the Earth, about 4.55 billion years. That value still stands. It required eliminating contamination, the same contamination that revealed a larger truth. Patterson never described himself as a crusader. He avoided rhetoric. He focused on data, on comparisons, on records preserved in nature. Ice does not argue. Sediment does not lobby. Atoms decay at fixed rates. The environment recorded what humans added, and recorded when they stopped. The removal of lead from gasoline is now considered one of the most successful public health interventions in history. Millions of children were spared neurological damage. Entire populations saw measurable improvement. No monument marks this. No fuel pump mentions his name. Clair Patterson did not invent a technology. He did not lead a movement. He did not hold power. He measured carefully. He noticed inconsistency. He refused to ignore it. The Earth's age is written in stone. The history of contamination is written in ice. Both records told the truth. Because one man insisted on clean data, lead did not disappear by chance. It was identified, tracked, and removed. That process began quietly, in a laboratory, with numbers that would not make sense, and with a scientist who chose accuracy over comfort. The data did not require belief. It required measurement. When lead was added to fuel, it appeared in ice, soil, and blood. When lead was removed, it declined in all three. The record is continuous. The cause is identifiable. The outcome is measurable. That sequence remains one of the clearest demonstrations of human-made environmental change ever documented. It was established without slogans, without campaigns, and without compromise. Only numbers compared across time.